Group 3 consisted of the members Darius Hinds, Amir Ifill, Simeon Jackman, Johann Scantlebury, Davica Lopez-Bishop, and Andre Knight. The practical goal was to measure different activity occurring at the beach. The first activity was to measure longshore drift using a grapefruit and timer. Group 3 measured an average of 1 minute and 50 seconds to travel 5 meters, whereas Groups 2 and 4 measured averages of 54.67 seconds and 39.52 seconds to travel the same 5 meters. This may be due to their locations, as Groups 2 and 4 location on the beach featured more high-energy waves. The longshore drift of Group 2 and 4 also traveled to the left, whereas Group 3's traveled to the right. Second activity involved the breakers. The first was to measure the top height of breaking waves. Groups 3 and 4 measured waves of 2 feet 10 inches and 2 feet 9 inches respectively, whereas Group 2 measured a massive 9-foot wave. The difference for wave height could only be explained as, they had a much steeper part of the beach for them. For all groups, the waves approached from the left, which would have been, the west in our regard. The beach was also found to have plunging breakers, which would indicate it contains a slope as you go from sea onto the beach. This slope could have been further exaggerated by the effects of Hurricane Beryl during the earlier months of the hurricane season. Hurricane Beryl had caused the erosion of the beaches along the western coast as it took away a lot of the sand during its passing by of the island. The third group activity was to measure the beach profile, and it was found to have a slope of 6.62 centimeters, which would mean the beach is not that steep a beach. It has a more gradual slope, but that might just be the area which we measured. As we went further north on the beach, it had a more intense slope, but we did not get that group's data. The fourth activity was concerning measuring wind speed. The day was a generally windless day. At one point, Groups 3 and 4 were able to measure speeds of 2.5 miles per hour and 2.2 miles per hour. The fifth activity involved collecting beach sediments from different distances regarding the water, which were by the water, the middle of the beach face, and above the high tide mark, to determine the energy of the beach. The energy of the beach would be determined by the size of the particles, and as this is a sand beach, this would indicate that the beach was rather high energy, but depositional high energy instead of erosional, as the sand is built up on the actual beach. When you get closer into the water, it is very barren of sand. The final activity required us to get on a boat where we used equipment such as the depth sounder, the Secchi disc, various water samplers, and a water tester. The depth sounder was to determine the depth of water we were working with, which was found to be 5.9 meters. The GPS was used to determine our location, and that was shown in the actual video that we are sending. The Secchi discs were used to determine the furthest distance of visibility, which was found to be 4 meters. And 2 types of water samplers were deployed. One that can be used to test for dissolved oxygen as it caps underwater, and one that can be used for general water samples as you have to pour it out into sample bottles. The water tester was used to measure the different nutrients, pH, and dissolved oxygen of the water, and that will be shown in the video of itself.
In 3, 2, 1, mark. Let's press any ones right there. 13.1359. You gotta take a picture. 5.9 meters. So we have 5.9 meters.
Yeah, 5.9. I barely got that.
Alright, then you can just come down, select them.
Seriously? Oh, that ain't texting.
Darius, is it that? Yeah. 5.9 meters. 5.9 meters.
We can always look back at the probably 15-minute long video I'm going to take.
Alright, get it. So, you got two sets of water samplers. We have the Secudis, and then we have the probe that we can do last. Everybody remember what has to do with what?
No.
Yes? No?
I don't think so.
Alright, so what he has in his hand, that's the Secudis. That's going to measure
Visibility in the water.